So here we are. A city is developing plans for a community sports facility. Community members can suggest blah blah blah. Billy wants to include a 15 by 30 meter basketball court in the athletic center. He's putting it on an 8.5 by 11 inch sheet of paper. Which scale should Billy use to create as large a drawing as possible on the paper? So first, here's the basketball court. Okay, look like this. Billy's going to draw a picture a little nicer than mine. There's a three-point line, half court. Okay, this is 15 by 30. And let's go to let's just realize that this is a 1 by 2, right? I'm just going to set up this proportion now because it's going to help us get to the 8.5 by 11 piece of paper. Okay, so now here's our 8.5 by 11. And what we have to figure out is which will max out first. Will we max out the length? So will it fit on the paper like this? And the basketball court will fill out here, and then we'll have these margins over here, these open margins. Or is it going to fill out, when we put this drawing on, is it going to fill out this way? And we're going to have margins on the top and bottom. Well, this is a proportion. Let's see what happens if we, let me put this 11 over here. It makes more sense to put it there. Cross that out. Okay, so it's 1 by 2 versus 8.5 by 11. Well, if we match this side up to this side, right, it would be times 8.5. But look what happens to the length. When you multiply this, 2 by 8.5, it's too much. It's 17. We've run out of area. So we're screwed if we try to make this, to max this out. So instead, let's map 2 to 11. When we do it that way, you can see that instead we're multiplying by 5.5 to get to 11, and then 1.5, or I mean 1 times 5.5 gets us to 5.5. So in fact, when we put this scaled drawing onto here, it's going to go here to here. Basketball court will look like this on the piece of paper, and these margins on the side will look open. Here's our basketball court. All right, so this is our filled out basketball court, and these two sides are going to be open. And so now what's the scale? The scale is going to be 2 to 5.5. I mean, so I'm sorry, 2 to 11, or better yet, it's going to be, I'm sorry, ignore that. Here's 11 inches, and this 11 inches different distance is going to be equated with 30 feet. So it's 11 inches equals 30 meters, feet, 30 meters. And so let's see if we can see any of those in here. Nope. I'll just start over. I don't like any of these answers. 11 to 30. Oh, well, I disagree with these answers. It should be 11/30ths of an inch is equal to 1 meter. And it's not here. All right. Well, guess I'm slipping. Let's try 14. Let's see, do we have another problem on there? That's it. Well, if you hung on with me this long, you knew I was bound to run into a problem. Okay, 50 and 51. Let's go back to pencil. Let's raise the curtain. Okay, so the triangle ABC and JKL are similar. Find the ratio of their corresponding sides. Well, the ratio of the sides, they'll just stay consistent. You see how this, you go from 10 to 15, you're multiplying by 3/2, right, or 1.5. To go from 8 to 12, you're multiplying by 3.5. So the ratio of their corresponding sides, should be 3 to 2. Well, because A is given, I'm guessing because A is given first, and then ABC is given first, and JKL is given second. So it should be 3 to 2. I don't know why this 2 to 3 is here. I guess if they reverse this order here, I guess that was meant to throw you off. But there's that one. Amber wants to find the height of the tallest building in her city. She stands 323 feet away from her building, and there's there's tree 30 feet in front of her. Okay, so let's label this, because this is important. This is 30 feet from here to here, and she's 323 feet away from the building. So from here to here, all right there, we're by her feet. That is 323 feet, and the height, why heights always seem to be green, the height of this tree is 19. So this, you just have to pull the similar triangles out of this problem. This triangle will be similar to, what color? Dark tan, maybe? Will be similar to this triangle. And similar is just should be synonymous with proportional. You immediately go to proportions. So, oops, 30. Now let me write that in red. 30 is to 323, right? That's the little triangle, as 19 is to H. So that's this height of the building. Does 19 go into, 19 better go into, oh wait. Well, let's just do some algebra here. Let's flip both sides. H over 19 equals 323 over 30. And then multiply both sides by 19. And okay, this one we can do in our head. It's going to be this. So 19 over 30. Let me cross those out. 19 over 30 is a little less than 2/3, so we need a little less than 2/3. Oh no, we're going to be close. A little less than 2/3 of 323. Okay, we better do that because these two, it's one of these two, but I don't want to, they want it rounded to the nearest foot, and I'm not that good at estimating. 323 divided by 30. 204.6 or 205 is the answer. All right.